Welcome to ChronoLogic's USB-inSync demonstration video number 3, controlling USB-inSync hardware modules using LabVIEW. This video takes you through the LabVIEW example provided with the USB-inSync software platform. We will take you through two potential applications for this example. Step 1. Synchronously trigger multiple Legato modules using LabVIEW. For this demonstration, we require a PC running National Instruments LabVIEW software, an oscilloscope to display the output signals, a ChronoLogic Maestro master timing hub, and two ChronoLogic Legato universal timing devices with outputs connected to the inputs of the oscilloscope. Firstly, open LabVIEW and browse to the example project file folder which was installed when you installed ChronoLogic's Control Center. Open the USB-inSync project file. The example uses the ChronoLogic Simple Framework.net DLL to connect to the USB-inSync system. Open the main VI, which allows you to view the block diagram. In this example, the block diagram is already fully configured and ready to use. The block diagram includes some basic instructions on using LabVIEW with the USB-inSync system. In order to connect to the USB-inSync system, the example uses a LabVIEW.net constructor block. The example uses the USB modules property to return a list of all ChronoLogic modules attached to the PC. The example loops through all the modules and creates an instance for each module using the type and serial number. Now close the block diagram window and click the Run button to start a VI. The example will build a list of modules connected and display them in the main panel. In this case, we have two Legato universal timing devices connected. Now configure each module to output a square wave signal on channel 1. Set the time base to 10 nanoseconds, set it as an output, set the output to go high after 5,000 ticks, and to go low after 10,000 ticks. Set it to repeat this pattern. Now set the same output for the second Legato. You can now click the Synchronize button to sync both modules. The Synchronize indicator will highlight when they are synchronized. You can now click the Sync Start button to begin the synchronous output signals. We will repeat this process while looking at the oscilloscope screen. Here you can see the synchronous square wave outputs on the oscilloscope. By zooming in, we can highlight the highly accurate synchronization of the signals. At this point, we are looking at a 10 nanosecond grid on the oscilloscope, and we will lay the signals on top of each other to further demonstrate their synchronization. In step 2, we will synchronously trigger a Legato output and a data acquisition using the DAC 2500X. Firstly, replace one of the Legato modules with a DAC 2500X module. We can use the same USB and power cables. Connect the output of the Legato to the input of the DAC 2500X. We will also loop the output of the Legato back into one of its inputs in order to display the signal on the LabVIEW graph. Now we repeat the run procedure from step 1 to identify the DAC and Legato modules. Configure the Legato output to produce a square wave signal. configure the DAC 2500 for a sample rate of 100 kilosamples per second. Now synchronize the modules and click Sync Start. Input data from each module is now shown on the LabVIEW graph. This data is synchronous. However, it appears different due to the way that LabVIEW displays the data. This is a simple example of synchronous triggering and data acquisition using LabVIEW and USB-inSync hardware modules.